such thing as a perfectly straight line.
The geometry class would say otherwise, but...
To the, atom of molecule. Perfectly straight.
I don't know.
Obviously, you would say like drawing on a ruler is perfectly straight, but it's not. If you really look.
Is the ruler perfectly straight?
That's what I'm saying. It's not.
Yeah.
Didn't
We
we learn-
do synthetic division on Monday.
Yeah.
Yeah, we have the notes.
Yeah.
Did you understand that?
Monday, or was that-
That was Monday.
Then we took that.
That was the day you
Okay, okay,
Good
yeah.
luck.
So we did that Monday,
How
and
can I do
yesterday we did practice with
test
it,
corrections on
and
that
I took it out
test?
the door.
And I did not do good.
How do you do the corrections?
Yeah.
Yes.
Get the test and then fix the problems.
Oh, if you
Like
want,
just
I can do
like
it.
complete them again? You mean just like complete them again? And that's
Yeah,
it?
like we were going to get the right answer.
Okay, I don't think she found that test. Because I asked for it. Unless maybe
It's
I did
probably
get
in
I
one
did
of
get
those
it back.
baskets.
Actually.
Okay.
All right, we're gonna, so you guys can put this probably in your notes. Well, this isn't quite the note yet, but it's gonna get us there. So you can
My
put it
work
before
and my
you.
notes are all.
Okay, that's fine, that works.
I have notes and pictures.
Notes and pictures, oh, you're doing it on
He
the.
writes on the whiteboard and then takes a picture of it.
That's okay, at least he has a form of it. Okay, so sketching polynomials. This is what I'm gonna call this little section. Okay, so the polynomial we're going to use is x to the fourth plus x cubed minus 7x squared minus x plus 6. And then I'm just going to draw the graph over here, or x and y axes. Not quite as straight as just a very simple line. It's pretty straight.
You literally can't write the
Is anything straight on this?
Yeah,
Is anything actually straight?
that's what I'm saying. Nothing.
I mean, definition
You're not
of
allowed
straight
to
as in a
talk.
line,
Yeah. I'm
but good
sure
try.
why.
Someone tried to pull that on me when I told them nothing is straight. Okay,
They're different.
so what can you guys tell me about this polynomial?
It has X somewhere.
Hold on.
To the fourth degree of the
I'll wait till everyone's quiet. Hold on, Ron.
Bing, bada, boom.
No questions?
So,
You making fun
Oh,
of me?
yeah, so put this in your notes.
See if I can get the same song.
sorry.
No, you're okay.
I do not have a charger. Stop asking.
I see what you're saying.
An iPad charger?
Yes.
I don't have one of those either, unfortunately.
What
You
can I
had charts?
say? Bada, bing, bada, boom.
When I walk in, I'm the king of the room.
Just start rapping.
Look, I have small amounts of bracket. Is that what you were trying to do? Yes.
Yeah, I just
Punto,
wanted you to sing
get
the
them in your
song.
notes, let's
I'm
go.
working on it. It's starting to
Okay, this is our polynomial. Our end goal is to try to sketch this polynomial. Can we do that yet?
No.
We need to know what we know about it first, right?
Wow.
Okay, so what can you tell me about this polynomial right now?
Y at 6.
Y-intercept at 6. So 0, 6. All right. What else do we know?
It's to the 4th degree,
It's a 4th degree polynomial.
which means I can have 1 or 3 extrema.
Okay, hold on. That's good. So extrema.
I always want to say extremity.
So Kevin said we could have 3 or 1 extrema. What else do we know?
Sorry, I'm kind of focused on
It's okay.
Guess we could.
It's a what? Okay, so it's a parabola.
Let's see if it's even or odd.
What? So
That's what it said.
not necessarily. Hold on. So that's odd. It's an even degree, right? Because it's 4th. So what is our end behavior going to look like?
As x approaches f.
Field goals? Okay, so how do we write that?
As x approaches infinity. F of x approaches infinity.
Okay. So our first one is as x approaches infinity.
As x approaches negative infinity.
F of x approaches infinity.
Yes.
And then we're going negative infinity, looking to the left.
Still goes infinity.
We're still going to infinity because it looks like this. This is our end behavior where our arrows would be. Field goal.
Wide left.
Okay, could we sketch this graph as it is right now?
No. Because I don't know how.
You don't know how to, why not? Okay, so Logan says he's not quite sure how to sketch this graph. What else is important to sketch this graph? X-intercepts. Do we know those?
Yes, we
Looking
can
at
find
this?
them.
Jiffy.
So x-intercepts, that's important. But do we know them looking at standard form right now?
Now, you got a factor. Well, you can't.
We can find them.
You know factors.
Well, we need to get the factors, right? Because the factors give us what?
What if we divide out our factors?
So factors give us x-intercepts.
What if we divide out our factors?
Divide out our factors, okay, but do we have one factor that we know yet?
No.
Do we know any factors right now?
Yes.
What factors do we know, Noah?
Well, we
P
know
over
0,
Q.
6.
We know P
That's
over
not
Q.
actually-
But that's a
Not a
y-intercept.
factor.
So do we know any factors?
P over Q.
Okay, so we would need a calculator
Starting to feel like
at this point.
sticking
Okay, so let's just say we don't have calculators, our batteries are all dead. Because they pretty much work. We can't use a calculator, so we're going to do it mathematically.
Oh, it's easy.
Yeah, P over
It's
Q.
easy.
Prayers.
Prayers.
Oh, Father, pour all people have received.
Okay, so that's where we're going to get into our notes. Notes.
These notes.
And we're going to find the roots. So we're going to find our roots, which is our x-intercepts, which is our zeros, without using a calculator.
What?
Okay, so we call this our rational root theorem.
What in standard notation?
Actually, how much space do we need to leave? Let's see, what do we write? Okay, that's fine.
T, not an X.
Don't judge me for my names. It's all theater kids have to do with.
Theorem or theorem?
All theater kids have to do with waiting on curtain call.
Theorem.
The other day we literally just-
T-H-E-O-R-E-M.
What hydration?
What an arc destination?
Oh, I should probably. Can I move this up? Is everyone okay with that?
Yes, please. All my fashion route.
Rational root theorem. Okay, so what does rational mean?
It is not
Not
irrational.
irrational.
It means it's not irrational. Okay, so what's an example of an irrational number?
Pi.
Pi, E,
E. Or Euler's.
Euler's number. Okay, So what do those numbers have? What is
They go on
pi?
forever without repeating.
Without repeating.
Something like
Okay,
that.
so if we don't want to be irrational, we don't want to go on forever without repeating. So rational mean we can write it as like a fraction, because we couldn't write pi as a fraction.
Like, almost right, that's a fraction.
No, because there's no.
That's
22
like
over
20,
7.
22.
But we've had to divide things by
Right?
pi,
That's
so
exactly
technically.
what is it?
22 over 7.
Okay. But you can't write it as its own fraction. Is that what you're saying?
22
You can't
over 7, isn't it?
Yeah,
Does that give you
that's what I
every
learned.
It's not 22 over 7.
That's what I learned in 8th grade.
There's no fraction.
Yeah.
Pi over 1.
It's like it's like the closest to
So I'm
pi.
thinking what they gave you was the rounded version of it.
Yeah.
If we're looking at the exact, we want to look at rational numbers which give us fractions. So it's a ratio of one integer over another integer.
Yeah.
Okay?
It's way off.
What if you do
An exact ratio,
if you
not
do
like
pi
pi.
over something? What if you do pi over 2.17?
I don't know. We don't care about pi right now. Okay, so
Did you just say we don't care about that?
right now. I don't care about pi right now. Because we're doing rational numbers, not irrational numbers. Okay, so rational root theorem. Possible rational roots of any polynomial come from the factors of the constant. And we're going to call that P. Divided by the factors of the leading coefficient. We're going to call that Q. So P over Q. Thanks, Kevin.
Yeah, no problem.
So possible rational roots of any polynomial come from the factors of the constant divided by the factors of the leading coefficient. So what's our constant in this polynomial?
Positive infinity.
So we've got x to the fourth, x cubed, negative 7x squared, negative x plus 6.
Nothing.
The y.
Nothing.
Yeah. Say it louder.
Our constant would be positive 6. Because it doesn't
Positive 6, our y-intercept. So our last term. And then what's our leading coefficient? 1. It's our first term. It's our leading number here. Okay? So if we're looking, and I might flip over the page actually to do these. Everyone have this down so I can turn the page?
Yeah.
What are you doing?
Yeah. What are you doing,
Do you need
Justin?
help?
Get yourself together.
Do you need assistance?
He needs a lot of assistance.
Kevin,
What?
Okay.
Watch her roast, Justin.
stop. Stop being a bully.
Yeah.
Well, that's what it's supposed to be.
A nice person.
Thanks, Miss Lucy.
What? Where?
Not in that direction right now. Okay, example. We need to look for our P. What's our P?
Positive 6.
Positive 6. So if P is positive 6, what's our